And I think the FAA wants that.
All right, let's go.
Asking for the.
Get started. Okay, everybody.
They don't care who you are.
Here we have William Rickert, a ISU student, and he's going to be talking about the design and assembly of electronics on a budget that is even justifiable to our students.
All right, how's everyone doing? I am William Rickert, as it says up there. I am talking about design and assembly of circuit boards at a budget even a student can justify. So let's get started. Like I said, I am William Rickert. And who am I? I am a veteran, a father of three, junior at Iowa State University, studying computer engineering. And I am a member of the Ice Age community. That is a cyber defense organization at Iowa State. And I've built more than 800 circuit boards in the basement of my apartment complex. That's my Twitter handle. I usually talk a lot about design and building electronics, how you can do it cheaply, interesting projects. So here's why I'm giving this talk. We are at a fantastic time for DIY electronics. It is at a price point where you can have a fail-fast mentality. You can make whatever you want, throw it at the wall. If it doesn't work, who cares? Move on. The badge life community is getting to be really big, so it's supporting a lot of creativity, a lot of really fun stuff right now. And also, one of my big mottos is, I love working with things I can hit with a hammer. If it's disobedient, there's some catharsis for you. So what this talk is, I'm giving a brief overview on everything you need to know to build your own circuit boards and how to design and build them. And it's basically, I'm calling it a speed run tutorial. What this talk is not is an in-depth tutorial on how to do any step along the way. There are better people than I that have very in-depth, very well-made tutorials out there, and I implore you to reach out and find those. So the way things used to be with printed circuit boards is, I was a part of a Twitter conversation that kind of started this for me. So this gentleman here is a high-level electrical engineer, and he was talking about 7 years ago, it was $100 for 100 millimeter by 100 millimeter printed circuit board. And Dave Jones from the EEV blog, hello, chimed in that that was very cheap. Even 10 years before that, so 17 years ago, you'd pay upwards of $500 just to start, and then tooling prices. These days, you have not that at all. So on the left here, this is OSH Park. They are one of the big stateside inexpensive manufacturers. And what they do is really clever. They will take a whole bunch of designs, concatenate them onto one board, and then send that to stateside manufacturers so that you save a lot of money. These other two here are Chinese manufacturers. You can get 10 circuit boards from them up to 100 millimeters by 100 millimeters for $5 and $17 to ship it in 2 days. So within a week, you can have 10 circuit boards for about 20 bucks. Obviously you're going to get better customer support with OSH Park, but the customer service isn't too bad with the Chinese manufacturers. Important terms to know that I'll be repeating a lot. First one is printed circuit boards, PCBs. Silkscreen and edge cuts are two parts of a PCB. They are the image that's on top, usually in white for silkscreen, and edge cuts is the outline of the board that they will cut, they will route in order to separate it from the larger panel. The footprint is the physical layout on the circuit board where your part will sit on it. And I'll have better visuals here in a couple of slides to explain that one a little bit more. So, as an overview of the process, so what you're going to do is you're going to start by writing some PCB art. You will then find whatever components you want to use in your design. You will create the schematic, apply footprints, do the PCB layout, so actually lay them out as you want them on the board, assemble it, do something, and profit. What we're all here for, right? So step one is optional. You want to do PCB art. So these are all examples that I've worked with for badge life, but even if you're not interested in badge life, this is still a very useful thing to do, because if you're working on a project and you want to fit it in an enclosure, you can start with this step, create it to the exact right size in a graphic arts program, and then move forward. So it's still very applicable. So, figuring we're at CornCon, I would step you guys through the process of making a corn-related badge. Why not? It'd be fun. So what I usually do, and if I'm just making something generic, I will go to Google Image Search, and they have this lovely option. You go to Tools, and then Line Drawing. So it will give you straight up line drawings. These are ready-made for badges. So select whatever image you want. I think I went with this guy here. And download it. Make sure you have the rights to use it, and import it into KiCad. Misspoke. Import it into Inkscape. So there is a lovely extension for Inkscape. It's called SVG to Shenzhen. And this is a very creaky program. If you lean on it, it makes weird noises. But it works fantastic when it does work. So what you do is you import it, you go to Extensions, SVG to Shenzhen, and then you prepare your document by entering what size you want to put it. Then you put your circuit board or your design in there, and you go to your layer selection menu. You'll notice when it first starts up, all your layers that you might be interested in are labeled disabled. Those are user editable fields. You just go through and remove the word disabled, and they work. I don't know why they designed it that way, but they did. So now that you have all your layers, you can make the art itself as a silkscreen layer, and then just draw a line around it for the edge cuts layer, so that they know what you want on it and what shape you want it in. Then you go again to Extensions, SVG to Shenzhen, and export KiCad. So you tell it where to go, what you want to export it as, and you can fuss with these, but generally you don't have to, and click Apply. So next, after you know what you want your design to look like, you need to figure out what parts you want to have on it. And you have a lot of options these days. So these first two options here, DigiKey and Mausner, are stateside electronics parts warehouses. And they are very handy, they're quick. Usually, DigiKey especially has one of their large plants in Minnesota, so just standard USPS shipping will get here in about 2 days. Alternatively, LCSC is a Chinese version of that. They are very inexpensive. However, you are paying larger shipping prices. And the last option here, Alibaba, is a direct Chinese manufacturer connection. You can get parts very inexpensive, but you can't bundle them together, and you have to be wary of scams. A lot of times you see inflated specs on a lot of things, specifically batteries and other things like that. Now, it is a lot cheaper to buy in China. So this first chip here that I have as an example is a USB to serial device. And it is, where are you? $1.23 each out of 100. And the second device here is the CH330 USB to serial. It's my favorite part. And even right here, for a 30 quantity, it's 30 cents a piece. These things do the same function, but there's a vast difference of price. And again, down here, this is the STM32F42 microcontroller. These are the same price, but here is DigiKey in the States, $1.57, and here is LCSC again, 92 cents. So it's all trade-offs. You gotta decide if it's more important to get it inexpensively or to get it quickly. It's up to you.
How long do you have to wait when you order out of China?
So normally it's DHL, so it's 2 days shipping.
Oh, you pay a lot of money for that, don't you?
About $17.
Wow.
Yeah, so it's not as bad as you would think. If you go to Alibaba, the prices are generally higher there. I wonder if it's just because people that are shipping less. LCSC does a fair amount of business, so they get better deals, is my best guess. Yeah, when I first found LCSC, I went a little overboard. But that was a fun day. So here's the best thing about electronics these days, is that part manufacturers want you to use their parts. So in the data sheets, like for example, if you're using a software project, you go through, you find whatever example code they have, you jam it into your project and it works. Well, the exact same thing happens in electronics. So you find whatever part looks interesting, you look at their data sheet and they just provide, here's everything you could possibly need to run this. So this is a voltage regulator. So on one side you put whatever your battery is, on the other side you put a microcontroller, and you get the right voltage. This one is a STM32F042 microcontroller. And they're showing you everything you could possibly need to hook up to it so that it just works like you want it to. This is the exact same thing as the example code. You can scotch tape this straight into your design and it'll work like you would hope. Now here's another one. This is a Chinese only data sheet. But can anyone tell me what they think this might do? Exactly. So schematics are language neutral. It doesn't matter what language you speak. You can still see, okay, USB, here's a chip, and here's an output. I know what capacitors look like. So you just copy that into your schematic and it works. This is my favorite part. I used them on the B-Sides Iowa badge, saved the price of $1 per badge.
Wait, are you saying you just send the schematic to the manufacturer and they send you all the components?
Well, you have to design your own schematic, so that's the very next step. So you can take these reference schematics and use them in your own designs. So KiCad is the tool I use. It's open source. It's available on all the operating systems. And within KiCad, there's a tool called eSchema. Not sure if that's what it's called. There's not even good consensus on whether this is called KiCad or KiCad, so I'm not even going to touch eSchema. So this is what eSchema is here, and this is a simple badge here that I have laid out. This is the corn badge that I was talking about. And all of this is reference design. So right here I have a USB-C port with 2 resistors that makes the computer say, okay, this is just a standard USB 2.0. I have 2 button and a switch. I have the reference design for the microcontroller right here. Reference design for the voltage regulator. A battery. A reference design for the battery charger. And this is my only real contribution here in the middle. I wired up some LEDs to a resistor. That's the only new thing I did. Everything else is reference designs. So you take these, and you take, so all of these things on these circuit boards, then you have to map them to a footprint. Now, you use this button right here within eSchema, and how you find footprints can be a little bit hairy. So you use the footprint reference from the data sheet as a starting point. DigiKey and Mausner, now one of the nice reasons why it's nice to use them is a lot of times they will give you the footprints for the part. Additionally, there are industry standard footprints that you will frequently find, okay, this is a standard thing, I can just plug it straight across. The worst case scenario is you have to use the reference from the data sheet to draw out your footprint within another tool within KiCad. Now, a little bit better explanation of what a footprint is here is one of the parts, and the footprint is just the part of the part that actually touches the circuit board and conducts electricity. So all you have to worry about is what parts are actually going to touch my circuit board. So you use the KiCad's footprints assignment window. So on the left here is all the libraries that have footprints within them. The center field is a list of all of the schematic symbols that you have used. And you just go down the list and you assign a footprint to every individual item. That's all there is to that. Click OK, and you click this button to generate a netlist. So the netlist is simply a list of all of the parts within the schematic and what footprint there is and what each line of the footprint is connected to on the circuit board. So you take that and you get to go do your PCB layout. This is the part that I really find fun. It's basically arts and crafts on a computer. You know, you use your netlist and you lay out your circuit board. So I have my lovely corn here. All that you see here is this bluish is my silk screen, so that'll be the art that's on top of it. And it's a little hard to see, but there's this yellow line here. That is my edge cuts, where the circuit board will be cut out from the panel. So you import, actually you can see the button right here. You click Net, and you import all of the footprints that you assigned, and KiCad just throws them down right next to it. And all you have to do is then take each individual part, put where you want it on the board, and put wires in between it. So here is all my parts laid out roughly where I want them, and you connect wires in between them. So whenever you click on part of a footprint, KiCad will point out, okay, this part you want to wire up here, and you just trace a little wire to it. That's all there is to it. Here on the right is KiCad's built-in rendering engine to show you what things will look like. Now, I don't generally go through the effort to assign 3D shapes to all the footprints, So you can see some are populated here that looks like there's a part, some are just the raw footprint. But it gives you an idea of how the layout's going to work and what you need to do to make sure that nothing bumps into each other. I previously built a board that was impossible to put a battery into because I didn't pay attention to that. And there was things on either side. Oh well. Expensive, fail fast.
You gotta keep moving things around so that your runs don't cross.
And that's what I had to end up doing. I just didn't realize it at first. So, once you're happy with that, you need to go to the plot dialog within KiCad. And what this is will generate what's called a Gerber file. A Gerber file is an industry standard way of laying out circuit boards so that manufacturers know, okay, this is how you want your board to be. The manufacturer will tell you in excruciating detail what settings you need to use to make this work. But I have very rarely come across a situation where I had to edit these. So you just generally go with whatever defaults are here. You say generate drill files and plot. And that's all you do. You zip up the files and you decide which manufacturer you want to use and send it to them. So we have our 3 manufacturers again. And one thing that I do think makes your life so much easier is I always make sure to buy a stencil. I believe we'll be covering that in a couple of slides. So this is JLC PCB. They are my preferred supplier. And it's a little hard to see here, but that says $2 for 5 boards, plus $17 to ship it to you in a week. So our little CornCon badge, 20 bucks. It's pretty easy for the circuit board. Alternatively, here is OSH Park, the stateside supplier. They are charging $44.05. Oh, one thing of note, it's just off the bottom here, but you have several different color options. So you can go with green, black, blue, red, or yellow circuit boards. OSH Park only does purple, but they do have better customer support, and their built-in rendering engine is way nicer. So sometimes, even if I just want to check a design, I use their render engine to make sure that what I'm doing is right. Now, a brief note about stencils. I'll cover the use of stencil here in just a couple of slides, but you order them through the same website that you order your circuit board. And what you can see here is the stencils are relatively cheap, between $7 and $13 a stencil. And there are clever ways to make it even cheaper. So there are open source programs, in this case this is GerbV, and you can actually combine stencils together. So I have actually 4 different designs all right here next to each other. And I have one stencil at home that I have 10 different designs on. So that's 70 cents per project to make my life much easier.
What's a stencil again?
I haven't covered it yet. It's a bit out of order because,
Okay.
yeah.
Is that basically so that you can reorder without some of this setup work?
Well, here's a stencil right here. And all it is a sheet of metal where they have laser etched all the parts in it where that you want to apply solder paste so that you can solder to. So in one go, you can apply all the solder to your entire circuit board. And it's how you do large scale assembly. And even with 1 or 2 off designs, this makes it way easier. So, on to assembly. What you'll need for this step is the circuit boards that you've just designed, a stencil, the parts you want to use, solder paste, tweezers, and isopropyl alcohol. This is all the parts that I took to DEF CON this year. So, like I just showed you, this is our stencil. This is the circuit board under test. So, what you will do is you will use your stencil as a guide to apply solder paste. Solder paste, as you can see here, are microscopic little balls of solder in a flux solution. So instead of soldering the old way where you have an iron, you apply solder, this you apply the solder paste, and it just sits there. Now, the really cool thing about solder paste is that it's slightly sticky, so that when you place your parts on top of the solder paste, they stay put. Additionally, you don't have to worry too much about alignment. Solder paste, once it turns liquid, has surface tension that will actually pull your parts into place and affix them there. So this is a very forgiving process. This, in my opinion, is easier than hand soldering. One thing that is really important to note is that there are 2 different types of solder paste, leaded and lead-free. Leaded takes lower temperatures and is more forgiving and is easier to use. However, lead is very toxic. I have small children at home, so I take a lot of precautions. I wear gloves, wash your hands, wear a respirator, and get quarterly blood tests for everyone in my house. Because lead does very nasty things, so be very aware of that.
You like lead that much better to go through all that, huh?
Yeah, you know, I like my kids. So you can see here, solder place. So what you do is you take your circuit board, you put your stencil on top of it, and you apply some solder paste to it, and just use a squeegee, a credit card or something similar, to scrape along the stencil. So the idea is you only leave solder paste in the places where there is metal on your circuit board. And you only want to leave about the thickness of the stencil's worth of solder paste there. So you can see here, this is a very, whoever did these, this is not my picture, did a very nice job. You don't need to be this neat necessarily. You should strive for it. But if you happen to be short, it's fine. It'll take care of it on its own. So once you have your solder paste there, you place your components on top of the solder paste. And the solder paste is slightly sticky, so things generally stay put. This makes it very easy. And this is actually part of the B-Sides Iowa badge after I refloated. You can see it makes a very neat result. So once you have your circuit board, your solder paste, and your parts all in one place, what you want to do is you want to heat up your circuit board following this reflow curve. This is from the data sheet for the solder paste. And so what you want to do is, as quickly as possible, come up to 100 degrees Celsius. Then slowly, and bring yourself up to 150 degrees Celsius. And then again, probably about as fast as you can, bring it up to 235 degrees Celsius. Hold there for a brief time and allow it to cool off. This is ideal circumstances. You will have the best yield of products if you follow this as best you can. However, it is somewhat forgiving. You don't need to follow this, but you can if you should. You should if you can, even better. So, this is how I've been building most of my boards. This is a toaster oven. $100 Panasonic toaster oven from Walmart. And I bought this just before about 2 weeks before B-Sides Iowa, when I had 300 badges due. The university said, no, you cannot borrow our reflow oven. So I panicked, went to Walmart and bought this guy. And this is actually pretty simple. All you do is buy basically any toaster oven, pull it apart, increase the insulation if you can, yank out the reflow or the controller, and provide your own. There are kits online that make very nice reflow controllers, but you don't need it. This is the B-Sides Iowa badge, or any microcontroller will work. I have a temperature sensor here and a little display. Actually, I should say this is a thermocouple reader. And then you can see this braided wire going off. That just is a thermocouple that goes right to the toaster oven. This is all of about $20. It doesn't take a whole lot. However, I did find out there is a problem with this setup. It has an overflow bug. If you take it above 472 degrees Fahrenheit, it will overflow and think it's 32 degrees Fahrenheit inside. In which case your controller will say, oh my God, the temperature's too low, and turn it on max for as long as it can. I turned around and there was a small fire in my basement. My wife was not amused. So with that, the code is available on my GitHub if you're interested. I did fix that bug. It has to do with how the two's complement conversion worked. But that was an entertaining evening. So what you can see here is one of my initial test runs with the toaster oven setup. I have it's hard to see, that's the curve I'm trying to follow, and just a USB serial shell. It was very trivial. You can imagine my surprise when a few months later I found out there's an even easier option. Instead of going through and building your own controller and beefing up your oven, you can buy the cheapest skillet at Walmart for $20. Now, when I bought this, I thought I'd be clever, and I hooked up my reflow controller in it, and I set up temperature monitoring, It's almost infuriating how perfectly this thing follows a reflow curve just on its own. Like, my addition helped nothing. So all you do, so we again have our assembly of circuit boards, solder paste, and parts. You place it, wrong way. You place it here on the skillet, crank it up to max, and sit there for 3 minutes and 20 seconds until you see silver solder, and you turn it off. And that is literally all you have to do. I built 600 circuit boards for DEF CON that I sold at DEF CON using this method. It is trivially easy. Anyone can do this.
Sell them for $20 each.
Yes. Yeah.
Nice.
You weren't kidding when you said profit.
Yeah. Well, so I should have had an internship this
What
summer.
made you even think of using that?
Someone on the Badge Life community on Twitter said, "Hey, this works," and I was like, "Okay, I gotta try that." At Hamster on Twitter, he's a really good guy. So yeah, that was my addition. It did not help. Additional tools that are somewhat useful here is hello. So a hot air rework station. This allows you to do spot fixes and do little solder jobs that would be hard to do with a soldering iron. I have done BGAs, which are parts that have all of the connections hidden underneath the chips. With just one of these, $39 gives you a lot of flexibility. These little dispenser bottles have been invaluable for isopropyl alcohol. You just pump on it a couple times with a rag and you're good to go. Little tweezer kit. These are all optional. If you're interested, every part of this process has been significantly cheaper than I expected. So it's really fun to be able to show it.
What do you do with the alcohol?
So these are little pump bottles, and there's a little cup on top. When you press down on it, the cup is filled up with whatever's in the bottle. They're for makeup, but they work perfectly for this.
Cleans up the flux.
Get rid of the flux, okay?
Yep. Oh, sorry, I misunderstood you. Yeah. You can use it to get rid of flux. I use that a lot to clean up stencils after I've used them, because you don't want to you'll have like little leftover solder paste, and so you get bad applications. So you can just clean with that. So our final total from our corn badge, so 10 printed circuit boards was $5, one stencil was $7. The parts for 10 were $17.25, I have that right here. Shipping from China was $17. I think I may have missed the point. The reason why LCSC is my favorite parts supplier in China is because their sister company is JLC PCB, so you can order your circuit boards and your parts from the same place and have them shipped together. So you're only paying one shipping charge. Your solder paste from Amazon is all of $11. The Walmart griddle, $20. So the total for making 10 badges with no supplies starting whatsoever is $77. 46 if you don't count the griddle and solder paste, because you can reuse those. The solder paste, it comes in a little tube. You'll get more than 10 badges worth out of that. These are some of the badges that I have worked on. Well, some of the circuit boards I worked on. An SDM32F42 test board with a battery, SAOs and totems, and a little DEF CON badge that didn't quite make it to DEF CON this year.
Do you breadboard these before you actually build a circuit board?
Not anymore. No, there is a clear back here, one of my splash screens I put. There you are. This SecKC star for the SecKC at DEF CON, SecKC party at DEF CON, uses a 2-transistor arrangement to blink. That one I did breadboard, but these days I rarely breadboard other than just making sure I'm sanity checking. And I don't do perf board at all whatsoever. Circuit boards are so easy and cheap that I'll just make extra ones. I've ordered circuit boards and noticed that there were small issues with them. One fun thing about JLC PCB is until it ships, you can add things to the order. So I've had a version 1 of my circuit board there and noticed there was an issue, so ordered the version 2 and they both ship together. I'm out $5. Oh well. And back to where we were. Here we go. Okay. This is a Raspberry Pi compute module dev board that I made up. little board to test a pure Chinesium chip that I never got working. This is if you've seen the rubber duckies, this is my version of a rubber ducky. This whole assembly here is $1.26. Circuit board, case and all. I did the B-Sides Iowa badge, and this is a Bluetooth laser tag game that I was playing with. All right, thank you guys for having me. I blasted through that because last talk went a bit long. I wanted to make sure we get to the closing ceremony. This is my GitHub. All of my designs are open source, and they are available there. This is my Twitter. I am constantly talking about circuit boards and fun projects. Hopefully they'll have this available after all. Is there any questions?
I do have. How often do your manufacturers for the boards make mistakes?
I've never encountered it. That used to be a thing that happened in the past from what I've told, but everything is computer controlled, so I've never seen a mistake. I've seen a lot of mistakes that I've made replicated that far. And I've had a lot of machine translated emails from Chinese suppliers saying, you know, all the best English, trying to get something clarified. It happens.
I noticed you were using KiCad.
Mm-hmm.
Is there a reason you decided to use that over, say, like Eagle or any other?
Eagle you have to pay for. I'm a college student. All of this is done on the thinnest shoestring I can manage.
Eagle is free to education.
I have
Is it?
I have a student
Oh,
license.
I wasn't aware of that.
Yeah, they
No,
give away. I work in K-12, so
Oh, okay.
it's free for even higher ed. You just can't use it for a commercial product.
I guess I'm kind of over that line then.
He's selling it.
Yeah, I don't know. I try to stick towards open source, and I only use Linux.
But that's if you make money. But you could have counted your trip to DEF CON as part of your expenses and you lost. So you make no money, right?
Man.
Yeah, that's
Yeah.
with all the Autodesk products. So I have
Yeah.
that Fusion.
Yeah, I need to sit down and learn Fusion because I want to start doing 3D printed enclosures for projects.
Oh, yeah.
Because there are some really cool things happening there in the backlight community.
So you said you don't do like for your design, since they're relatively off-the-shelf reference stuff. You don't do any like electrical verification, SPICE, or
So I'm starting to have to do that. This one I
Okay.
definitely did have to do
because
that.
I figured for some of the stuff, the timing.
Yeah, absolutely. Did not include the picture, but yeah. So this is a laser tag system that I was using an infrared signal with my own encoding to transfer user IDs as the shot.
Right.
And I had an FPGA wired up to the second hand that I was having all sorts of crazy
Yeah.
problems with. So yeah, as a junior, I'm starting to get to the classes where they formally teach that.
Yeah.
And that's a lot of fun. I'm really enjoying school right now.
Yeah. Let's go. You're a double E major?
Computery.
Computer. Okay.
Yep.
Have you ever looked at any of the art stuff that they're doing now? I've actually got some students that are interested in like either to do some advanced stenciling or like inkjet
Really?
across the.
Oh yes, I've read about some of that.
I don't know if they had it anywhere. It hasn't filtered down to K-12 yet, obviously.
Well, yeah.
I mean, it would hit the colleges first for affordable.
Yeah, I just saw a paper about that, doing an additional inkjetting for a second layer.
Yeah, wouldn't that be cool for art? And
That
stuff?
really would be,
Yeah.
yeah. I'm a little biased. Part of the reason why I really love Badge Life is that you are strictly limited to what you have.
Yeah.
If you can add too many colors, might muddle it some.
Well, the neat thing I found, students have found that if they leave copper on purpose but not have it connected electrically, it can actually make a darker color.
Absolutely.
Right, so you can play with halftones and you can do some really.
Yeah,
Which one did you take to DEF CON this year?
So all of these here in the middle are what I took DEF CON.
Okay.
Yeah.
I couldn't remember if I saw you or not.
I only have a relatively limited. I was there as part of the Badge Pirates SecKC group,
Yeah.
and so I worked on some of their designs. I only really helped with some of the battery stuff on their badge.
Were you at like the hardware hacking village?
Only a little bit.
Just a little bit?
Yeah, I was trying to sell things and help with Badge Pirates.
Cool.
How much more expensive is it for multicolor filter?
Not generally possible. That's what we were just talking about. So there is some new stuff here where you can get a second silk screen, but it's not generally available yet. There was one guy with DEF CON that I had it, and his boards were $70 a piece to have that option. So it's starting to become a thing, but it's not feasible yet. Yeah.
So how does that?
So these are SAOs. So you can see this little header right here. SAO is the shitty add-on. It's a badge thing.
Yeah.
And you can make use of this somewhat standardized 6-pin connector to have all sorts of things that plug into it and do different things. So these are 2 different circuit boards stacked on top of each other. Yeah. Can I see a hand over here? No? Right on. Well, this was my first talk. Thank you guys for having me. I had a lot of fun.
What was your favorite badge this year?
Ooh.